Then we have our descending colon. As it comes down, it makes sort of this S-shaped bend, which is called the sigmoid colon. And we finish at the rectum. Okay. We'll go briefly over the mesenteries of the large intestine. We'll talk a lot more about mesenteries on Monday. But our ascending and descending colon, you'll notice, are going to be fixed to the back of the abdominal wall. So these are going to be secondarily retroperitoneal structures, which means that they won't have a mesentery. But our other parts do. So the cecum is freely mobile, and the mesentery for that is called the mesocecum. The appendix has its own mesentery called the mesoappendix. Transverse colon is attached to the posterior wall by the transverse mesocolon, and the sigmoid is attached by the sigmoid mesocolon. A few other characteristics of the large intestine that you should note. The large intestine has these longitudinal ribbon-like bands of muscle called tenae coli. It also has these sort of balloon-like outpouchings running along its length, and these are called haustra. And you'll see a bunch of little blobs of fat covered by peritoneum called omental appendices. So these are three characteristics that are unique to the large intestine. All right, moving on to other organs. Next up is the liver. The liver is our largest internal organ. So the dissector says that your liver approximately weighs 2.5% of your body weight. So my liver would weigh about 3 3/4 pounds. For anyone who's terribly concerned about how much I weigh, you can work your way back from that. But not only does it weigh a lot, but as I said, it's gigantic. And it's going to be frustrating for doing your dissection today because the liver is just constantly going to be in your way. It's really big and it kind of crowds every other abdominal organ out of that upper right quadrant of the abdomen. And if we take a cross section of it, you can see that the liver fills this entire upper right part, but it also spreads over into the left. So the majority of the upper part of the abdomen is filled just by liver. The liver is divided up into a number of lobes. If we look at it anteriorly, we can see 2 of them. We have a very large right lobe and a somewhat smaller left lobe. And these are going to be separated from each other by a sagittally running ligament called the falciform ligament. And running through the inferior most part of the falciform ligament, you'll be able to feel a round structure. This is called the ligamentum teres of the liver. So teres just means round. So this is one of the round ligaments in the body, and this one happens to be in the liver. And this is another one of those remnants of fetal development, and we'll talk about it a little bit more later today. If we look at the inferior surface, we can still see our right and left lobe, but we can see a bunch of other structures here. So we find, on the inferior surface, we'll find the gallbladder. Here's that ligamentum teres running through. And then towards the posterior part, we have the inferior vena cava running along. And then another remnant of fetal development here, the ligamentum venosum. But these 4 structures are going to divide out 2 more lobes of the liver that we can only see in our inferior view. On the back side, we have this thin sort of tail-like lobe called the caudate lobe. And anteriorly, we have this square or rectangular shaped lobe called the quadrate lobe. So the names of these lobes sort of tell you something about where they are or what they look like. So quadrate is square-shaped, 4 sides. Caudate is on the back like a tail. So this is our caudate lobe. Now these lobes can be divided up in a couple of different ways. So if we look at them anatomically, so from the external surface, it looks like the caudate lobe and the quadrate lobe are both parts of the right lobe of the liver. So they're both directly connected. Our falciform ligament divides the quadrate lobe and the caudate lobe. onto the right side from the left lobe. But this is just what it looks like anatomically from the external surface. If we instead look at bile drainage or vasculature running to the different parts, the functional lobes are going to be divided over here in this line made by the groove for the gallbladder and where the inferior vena cava sits. So the quadrate and caudate lobes are functionally a part of the left lobe or the left liver, and the right lobe is its own separate entity. All right, more ligaments of the liver. So we already talked about the falciform ligament on the anterior surface. And these ligaments on the liver, like the other ligaments that we've been talking about, are just going to be reflections of peritoneum. So this is going to be a reflection of where we go from visceral peritoneum on the surface of the liver up towards, in this case, the anterior abdominal wall. Near the upper part, we have what's called the coronary ligament. So this sits sort of on top of and a little bit posterior of the liver. And again, this is just a reflection from visceral peritoneum on the surface of the liver to parietal peritoneum. In this case, it's going to be on the diaphragm. If we look at the liver in posterior view, we can see the rest of the coronary ligament. So here it is here. And we can see there's an area, a large part of the liver is not covered by peritoneum. So most of the other organs that we're going to see are covered completely by peritoneum, but the liver has this big area that is bare and is cleverly called the bare area of the liver. So you won't see that today. You'll be able to feel the coronary ligaments when we do our dissection today by reaching your hand up over the superior surface of the liver, and you'll see you can only reach so far and you get stuck. And that's going to be one of those reflections of peritoneum from the visceral surface onto the diaphragm. Next week, when we actually cut away the liver so we can move it around, you'll be able to see the bare area and the rest of the coronary ligament. And you'll be able to identify these other two named ligaments. On the right side, the coronary ligament will make this sharp bend, make sort of a triangle shape. So this is the right triangular ligament. And on the left side, it does the same for the left triangular ligament. And just to drive this home a little bit more, if we take a full cross-section, so this is showing our peritoneum, and our coronary ligament is going to be these areas where we have a reflection from visceral to parietal peritoneum. So it's not going to be a long structure like we see in those other ligaments that we talked about. It's just this short reflection as it switches from visceral to parietal. All right, as promised, we need to talk a little bit more about fetal circulation, everyone's favorite topic. We talked about this a bit in the heart. There were two shunts in the heart and adjacent vessels for getting fetal circulation to avoid going to the lungs. So one of them was this shunt going from the right to left atrium. What was that called?
Foraminal valley.
So the fossa ovalis is what it is in an adult. Foraminal valley was that shunt. And then we had this other shunt from the pulmonary trunk up to the arch of the aorta. And what was that called?
Ductus arteriosus.
Ductus arteriosus. Great. So now ultimately this blood that's coming into the fetus is going to be coming from the placenta. And then to get into the fetus, it runs through the umbilical vein. The umbilical vein is going to run in towards the liver. But we don't need to run that blood through the liver. There's no point in filtering it. So the ductus venosus is going to be a direct connection from the umbilical vein into the inferior vena cava. So we're going to sort of bypass the veins running through the liver. Our big vein that's going to run through the liver is the hepatic portal vein. So the ductus venosus is another one of these shunts to bypass pushing this blood through a structure that it doesn't need to go through. Right. And now a comparison between fetal and neonatal. We'll go over what each of these becomes. So our umbilical vein in the neonate will become the ligamentum teres of the liver. The ductus venosus will become the ligamentum venosum. So we've already seen both of these structures. So the ligamentum teres will run through the inferior part of the falciform ligament, and the ligamentum venosum you'll see on that inferior aspect of the liver. And just for fun, these are our umbilical arteries that are taking blood out of the fetus back to the placenta. And after birth, these are going to deteriorate into those medial umbilical folds. So here's our remnant of our umbilical vein running past the hepatic portal vein into our remnant of the ductus venosus, which would have directly connected to the inferior vena cava. Okay, a large part of your dissection today will involve dissecting apart this hepatoduodenal ligament, because unlike some of the other ligaments, like the hepatogastric ligament, this one contains a lot of structures that are actually quite important. In particular, we have a very large vein, the hepatic portal vein, which is carrying all of the venous blood from the gut structures into the liver. We also have the bile duct and the hepatic artery proper. So the hepatoduodenal ligament is not fixed to the back of the abdominal wall. There's a free edge to it here. So when you're going through your dissector, it says to stick your finger in this area. And this opening that is left behind the hepatoduodenal ligament is called the omental foramen, or the foramen of Winslow. And this is going to be a communication between two different regions of the abdomen that we'll talk about a little bit more on Monday. So this area behind the stomach is a separate region called the lesser sac, and then the rest of the abdomen is all interconnected and called the greater sac. On the base of the liver, we can see a region called the porta hepatis. Porta hepatis just means gateway to the liver, and this is where all of our vessels are going to enter into or leave from the liver. So this is sort of like the hilum of the lung, if you want to think of it that way. And there are three primary structures running through this area. So it's called the portal triad. So we have our common hepatic duct, which will be for bile draining out of the liver. We have our hepatic artery proper for bringing arterial blood into the liver, and our hepatic portal vein for bringing venous blood into the liver. Right, our next organ that we'll look for is called the gallbladder. And when you first open up the abdomen, you probably won't notice the gallbladder. So in this diagram, you can see it sticking out a little bit here. And it is a nice dark green color. So the only way you'll probably notice it when you open up your abdomen is if you have one that is stained really dark green. So these are filled with bile. And during the embalming process, a lot of times this bile leaches out and stains the region right around the gallbladder. So there is usually a really distinct green color to this area. If we overlay sort of a diagram of this green system here, this is called the biliary tree or the biliary system. So this is the drainage of bile through this region. So bile is going to be generated within the liver, and it will be stored in the gallbladder. So we look at it a little bit closer. So there's obviously a lot of small vessels that will connect up to form larger and larger bile vessels. And then we only really want you to know the last two. So we end up with a right and left hepatic duct that will join together to form the common hepatic duct. The gallbladder is attached to this biliary tree through its own duct called the cystic duct. And after the cystic duct and common hepatic duct join together, they're referred to as the bile duct. So we can look at this in a little bit more realistic fashion here. So here are our right and left hepatic ducts coming out of the liver, joining together to form the common hepatic duct. Here's the cystic duct joining it, and afterwards it will be called the bile duct. And then on Monday, we'll look more at where the bile is going to go from here when we talk about the pancreas. Right, and our last organ to discuss for today is the spleen. So the spleen we already mentioned before when we were talking about the splenic flexure. So the spleen is this sort of pinkish purplish structure up here in the upper left quadrant of the abdomen. So the spleen is one of these organs that is not related to digestion. The spleen is more a part of the circulatory and immune systems. So we'll talk about it here with the abdomen. We're not going to talk much about its function. I'll talk a little bit more about its function when we do the lymphatics lecture in a week or two. So for today, we'll just look at the anatomy of the spleen. So the spleen is jammed up in this upper left quadrant, and so it lies right up against the diaphragm. So our exterior surface is going to be our diaphragmatic surface. It's also in close contact with a number of other organs that are going to leave impressions on the spleen. So superiorly, it's in contact with the stomach, so we have a gastric impression. Posteriorly, it will be in contact with the left kidney, so we'll have a renal impression. And anteriorly and inferiorly, it'll be in contact with the colon, so we have a colon impression. And as a part of the circulatory system, we have a rich blood supply to the spleen, and the vessels that go to it are very kindly named the splenic artery and splenic vein. So as I said, the spleen is kind of jammed up in this upper left quadrant, which means it's right up against the body wall, but even though this is an abdominal organ, it's largely protected by the thoracic rib cage. However, since it's right up against the wall, if we get some sort of piercing injury to this region, particularly in the 9th and 10th intercostal spaces, we can do damage to the spleen, which because of its rich blood supply is a major problem. It will bleed profusely into the abdomen. This is a type of injury that needs to be attended to immediately. Which leads me to my favorite picture in the dissector. This should be the only figure that you will see in this class that depicts either attempted or successful murder. But this is demonstrating that if you get some sort of knife wound or stabbing wound through the 9th intercostal space, not only can you pierce the spleen, which will cause this prolific bleeding, but you'll also pass through that costodiaphragmatic recess, which means that you're going to pierce the pleural sac, which could have issues for your left lung. Yeah.
So diaphragmatic is posterior or anterior?
The diaphragmatic surface of the spleen?
Yeah.
More lateral.
Lateral?